All right, so this question right here, mixture of ethanol and methanol is burned in oxygen to produce 35 cm cube of carbon dioxide and 55 cm cube of water. This is from summer 21 question, variant 1-3. So this is May, June 2021, variant 1-3, question number 24. So let's go over this. Now they're saying complete combustion occurs and the two volumes of the products are measured at 101 kilopascals and 120 degrees Celsius. Now the first thing that we got to calculate the moles of these gases, right? But we can't really do that using the standard conditions or moles is equals to volume upon 24 because the pressure and temperature is different. You see that? So first thing we got to calculate is using PV is equals to nRT, we need to find out that what is the volume of 1 mole of gas at this pressure and this temperature. So we need, because we can't use the standard conditions because the temperature is not 25 and 1 atm. So let's see. So the pressure is 101 kilopascals. So we convert it to pascals, we multiply it by 1000. The volume is what we need to find. We need to find how much volume is of 1 mole under these conditions. Moles would be 1, value of R is 8.314, and the temperature is 120 plus 273. So that gives you the value of X, which comes out to be 0.03235, and this would be in meters cube. Let's convert it to dm cube. So that would be the volume of 1 mole of gas under these conditions would be 32.35 dm cube. Now, once we have this, we can find the moles of these gases, right? So we can do moles is equals to volume upon now 32.35 because the conditions are different. So let's find the moles of carbon dioxide. It's 35 cm cube. So moles is equals to 35 upon 1000 divided by 32.35. And this gives you the moles of carbon dioxide, which come out to be 1.08 10 to the power minus 3. Let's find the moles of water. Moles of water would be moles is equals to the volume, which is 55 upon 1000 upon 32.35. And the moles of water come out to be 1.7 10 to the power minus 3. So these are the moles of water. And these are the moles of carbon dioxide. Now they're saying that we need to find the ratio of ethanol and methanol burning in oxygen. So let's write the equation of ethanol and methanol burning in oxygen undergoing complete combustion. So let's see methanol, which is CH3OH plus O2, giving CO2 plus H2O. Now let's balance this. So you have 4 hydrogen here, so we'll put a 2 here, and that will make 3 upon 2 oxygen here. Then let's write the equation for ethanol, that is C2H5OH plus O2, giving 2CO2 plus 3H2O. And let's balance the oxygens now. So this will be 3 oxygens. Now, we don't know the moles of ethanol. We don't know the moles of methanol. So let's call the moles of ethanol. Let's call it Y. And let's call the moles of methanol X. So we have moles of methanol and we have moles of ethanol. We know that 1 mole of methanol gives 1 mole of carbon dioxide, 2 moles of water. 1 mole of ethanol gives 2 moles of carbon dioxide, 3 moles of water. So can I say that 1 mole of methanol gives 1 mole of carbon dioxide and 2 moles of water? And therefore, can I say that X moles of methanol would give X moles of carbon dioxide and 2X moles of water? Likewise, can I say 1 mole of ethanol gives 2 moles of carbon dioxide and 3 moles of water? And we've taken this value to be Y. So Y moles of ethanol would give 2Y of carbon dioxide and 3Y of water. Now, we know the total moles of carbon dioxide, which is 1.08 10 to the power minus 3. And we know the total moles of water is 1.7 10 to the power minus 3. So let's add the moles of carbon dioxide and make it equal to 1.8 10 to the power minus 3. So x plus 2y, these are the total moles of carbon dioxide, equals to 1.08 10 to the power minus 3. And let's add these two up, 2x plus 3y. So 2x plus 3y, this is equal to 1.7 10 to the power minus 3. Now, can we just substitute the value of x? I mean, can we just take these two equations and in place of x, can I write, so can I say, let's take this equation for example, and that will be 2 times, instead of x, can I write 1.08 10 to the power minus 3 minus 2y? So I've substituted the first equation in the second equation, and plus 3y is equals to 1.7 10 to the power minus 3, because I made this x is equals to 1.08 10 to the power minus 3 minus 2y, and then I substituted that here. Yes. So this right here comes in place of x in my second equation, and using this, I can find the value of y. And the value of y comes out to be, you calculate all of this, and the value of y comes out to be 4.6 10 to the power minus 4 moles. And the y corresponds to what? Ethanol. So can we say this is the moles for ethanol? 4.6 10 to the power minus 4. And now can I substitute the value of y into my first or the second equation and find the value of x? So can I say x plus 2 times 4.6 10 to the power minus 4 is equals to 1.08 10 to the power minus 3. So I substituted this value of y in the first equation. And now I will find the value of x. And x comes out to be 1.6 10 to the power minus 4 moles of, and we've taken x to be what? Methanol. So this would be the moles of methanol. Now you have the moles of methanol, you have the moles of ethanol. So can we take, the question says find the ratio of ethanol to methanol. So you need the ratio of y is to x, right? So you need the ratio 4.6 10 to the power minus 4 is to 1.6 10 to the power minus 4. And the ratio comes out to be what? 3 is to 1. The answer therefore is D. Hope this is clear.